to 26, okay? So just, let me use a couple of minutes to explain that one. So the quiz 6 is about, hidden Markov model where you have a latent variable z1, z2, let me do z3, z4. And then given this, you have x1, x2, x3, and x4, okay? So in the hidden Markov model where each of my, in order to answer those questions, you sort of have to imagine how the data are generated. You generate those z1, z2, z3, z4, they're called latent variables. They only take 2 different values. And given z, you can generate x1, x2, x3, and x4. And now, how we specify this model. If first of all, remember, let me use a different. So z1, z2, z3, z4 are so-called latent variables. For any, so for any random variables, z1, z2, z3, z4, their joint probability mass function, those represent, once I give a particular value, there's going to be a probability. And the following factorization is always okay, meaning I take the first one and times the second one given the prior z1 and times, then I move to z3, I have to give all the prior variables, z1 and z2, and times z4 given z1, z2, z3. So this factorization is always correct, no matter what are the underlying distribution for the 4 random variables. But here we assume so-called Markov chain with, meaning at every location, if you're conditioning on the prior history, what matters is only the most recent one. So we can just cross this, oops, sorry. Cross this one stay, and cross this. So in order to describe the Z sequence, you just need to know what is the distribution for the first one, they call the initial distribution. Once you know the observation for Z1, conditioning on Z1, you generate Z2. That's so-called transition probabilities. We will tell you, we have a table to tell you, okay, if ZT is equal to 1 and 2, and then ZT plus 1 is equal to 1 and 2, and you can fill in those probabilities. Given ZT is equal to 1, what is the chance of the next point is 1 or 2? Given ZT is equal to 2, what is the probability of the next point is going to be 1 or 2? So it's called transition probabilities. So once you know the initial distribution and this transition probabilities, you can calculate any sequence of this Z sequence. Now, once these sequences are given, then given each one of them, you know how to generate X1, how to generate X2, and go on, okay? And so this is called hidden Markov model. Now, in that quiz, whenever you are asking, for example, how to compute the probability of a particular sequence for Z1, Z2, and like this, that's easy. There's a particular value, right? You basically just use this factorization. You can calculate this probability, and that's easy. Now, how to compute, for example, the probability of X1? I think there is a question is calculate, what is the probability of X1, let's say equal to 1, right? How are you going to do that? Well, first, X1 is here. You cannot generate X1. You have to generate X1, you have to go through Z1, okay? So you can calculate this, the probability of this happen, use this principle, and it's kind of, this is a marginal, meaning this is equal to, I add one more variable, and I sum over all possible value of this variable. Okay, So the sum of these two, you sort of, because Z1 can only take two different values. So once you sum them over, you get the marginal of this. Now, how to compute this? Well, you go through that data generating process. You first generate Z1. So this will factorize as the probability of Z1 times X1 given Z1. Okay, so this probability and given Z1, how you generate X1. So this will be a product, each one of them, and you sum them together. Now, a much more difficult problem, the later question is asking you something like, what is the probability of Z1 equal to 1 and given? I forgot whether this is one of the probability, but it looked like this. X1 equal to 1, X2 equal to 1.
So one quick question here, right, Professor?
Uh-huh.
So here on the statement, right, it should be Z1 equal, Z1 equal to 2, right? Not
Oh, yeah, I think it's actually asked Z1 equal to 2, right? And so for this,
I'm talking
sorry,
above line.
This
above,
one?
Yes.
Yeah, this is Z. Oh, sorry. Oh, yeah. Z1 equal to 2. Yeah, you're right. Yes, Z1 equal to 2. Right. So now some of the later questions asking you like, what is Z1 equal to 1 conditioning on this 2? Now, if you know the data generating process, you feel like, well, if X1, X2 are involved and somehow the two hidden variables got to be generated in some way. So really what you need to compute, you have to do something involving 4 nodes. So I think it's better to answer that question, it's better to work with this calculate something like this. Let's calculate just in general, what is the probability of Z1 equal to 1, Z1 equal to 1. Let me do I and J, okay? And the IJ can take either 1, 2, like there are 4 possible choices for this pair because each one can take value 1 or 2. Given X1 equal to 1, X2 equal to 1, okay? So for this probability, I think it might be better for me to, actually it's okay to use this. This, by the definition of conditional probability, the numerator is equal to, it's just equal to the joint of this. Divided by the marginal, which is whatever the probability after the bar. Now, I mentioned in a Piazza note, how you compute the denominator, you use the same trick I mentioned before. You have to, this is a joint. You have this denominator is basically equal to the summation of the 4 probabilities. So the denominator is equal to the probability of Z1 equal to 1, Z2 equal to 1, X1 equal to 1. There are 4 probabilities where you just basically change to 1, 2, 2, 1, meaning you copy those, this gonna copy here, and plus probability of 2, 2. Okay. So you basically have to compute the joint probability of Z1, Z2 equal to 4 different values at that pair, and also X1, X2 equal to 1. Now those probabilities is a joint probability, so you use that what we described before, the kind of you calculate the probability by imagining how data are generated. You calculate what is the probability of Z1 equal to a particular value, and times the probability of observing Z2 given that Z1, and then times the probability of each of the X1, X2 given their individual value. So you can get the 4 probabilities. Once you have the 4 probabilities ready, you can calculate this kind of a conditional. Now, if I ask you, what is the conditional probability of only Z1, you basically just sum 2 probabilities. Z2 equal to 1 or Z2 equal to 2, you sum them together, you get the condition of only Z1. Okay, so this is for the hidden Markov model, and hidden Markov model actually used a lot in practice. I want to just add one more comment. All this, like week 6, I think we talk about latent class model. The whole goal is just try to, model a complicated data distribution, which the data here are the X. because they're correlated, they're complicated, but we can make them as a simpler model by introducing some latent variables. For example, a lot of times in like in recommendation system, when Spotify is trying to recommend the music, they actually try to guess what's your current latent status. Are you running? Are you walking? Are you driving a car? Because depending on that contextual information, the recommendation could be different. I mean, I guess similar for Amazon, and similar for the kind of a smart thermostat you used in your house. They also try to guess what's the environment, if people are in the home or not in the home, and then they can adjust the temperature accordingly. Those all actually depends on some kind of a hidden Markov model, and or like kind of latent structure model there. Okay,